right. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Okay, so in this next couple of days, we're going to spend whatever time people want reviewing. There's 6 chapters. I'm not going to attempt to blow through all 6 chapters. I'm basically just going to answer whatever questions you or anyone else that shows up has, and that's what we'll do. So today you said you had some questions from the test. So let's take a look at those. Do you want to share them? Do you want to just tell me what they are? What do you want to do?
So what I wanted, can you go through each formula, like the PERT one and then the A equals P?
Yeah.
And then with like a couple of examples for each.
Sure. Okay. Let me turn to chapter 11 and we will do just that very thing. Let's see here. Just a minute. Okay. So the first formula that we looked at was this one. And that was the compound interest formula. And we use that when the interest is compounded not continuously. So if it's annually or semi-annually or quarterly or monthly or daily, but it's not continuously, we use that formula, okay? If we have a situation where the interest or a population is compounded continuously, that's when we use this formula. Let's take a look at an example for the first formula. Let me find one here. Let's see here. Okay. This says if $500 is deposited in an account paying 8.5% annual interest, compounded semi-annually, how long will it take for the account to increase to $800? So the key word in that whole thing is that it's semi-annually. So that means we're going to use this first formula. Okay. Now, $500 is deposited. So P is $500 in an account paying 8.5% annual interest. So R is 8.5%, which would be 0.085. Compounded semi-annually, so K is 2, that's twice a year. How long will it take for the account to increase to $800? So the final amount is $800, and the unknown is the time. Okay? So we're going to plug all that information in, and we're going to get the following. $800 equals $500 times 1 plus 0.085 all over 2 raised to the power 2t. The next thing I'm going to do, I'm going to divide both sides by the $500. Okay, so on the left side, the dollar signs will go and 1, 2 zeros will go. So I'm going to have 8/5 equals, on the right, those will all go. Let's see. I can take 0.085 and divide it by 2. So this becomes 1 plus 0.0425. which then becomes 1.0425 to the 2t power. So this simplified into that, simplified into that. Are you okay with that?
Yes.
Yeah. Greg, welcome. We're looking at some questions from the Chapter 11 test that you folks took yesterday. All right. So now I can take this equation and write it in logarithmic form, and I get log base 1.0425 of 8/5 equals 2t. Okay. Now, I'm going to multiply both sides by 1/2. So then I've got t equals, and I'm going to change the 1/2 to 0.5 just because it'll be easier to work with. Okay, so I've got t equals 0.5 log base 1.0425 of 8/5. Still with me?
Yes.
All right, I'm going to go to the next screen. I'm going to recopy that. T equals 0.5 log 8/5 base 1.0425. And I'm going to use the change of base formula. So this becomes 0.5 log of 8/5 divided by log of 1.0425. Now I'm going to punch that into the calculator. 0.5, let's see here, 0.5 log of 8/5 divided by log of 1.0425. And when I do that, just a minute here. I get 5.646, and let's see, it said to round, it didn't say, it just rounds to the nearest 1/10 of a year, so they say about 5.6 years. Okay, you all right with that?
Yes.
Now let's go back and let's use the same information, but instead let's say that it was $500 is deposited in the account paying 8.5% annual interest, compounded continuously. How long will it take for the account to reach $800? Okay, so we're going to use the same A, the same P, the same R. We're going to find T, but now K is continuous, so we don't use that first formula. We use this one. All right?
Yes.
Let me ask you this. Do you think it's going to take more time or less time to get to $800 if it's compounded continuously?
The less?
Right. So it should be less than that. So let's see what happens. Okay. So $800 equals $500 e raised to the 0.085 t. Okay. Again, I need to divide both sides by the $500. So this goes away, and this goes away, and this goes away, and I have 8/5 equals e to the 0.085 t power. Okay. This becomes log base e of 8/5 equals 0.085 t. But log base e is just natural log. So I've got the natural log of 8/5 is 0.085 t. I will divide both sides by 0.085 5. So t equals the natural log of 8/5 divided by 0.0. I keep putting extra decimal points in there. Let's see what we get for that. So natural log of 8/5 divided by 0.085. And I get 5.529. So rounding to the nearest 10th. So it's 5.5 years instead of 5.6 years. So as you and I predicted, it took less time. But the difference in the two problems was the first one semi-annually, the second one continuously. Now let's expand on that. If you're dealing with a population that's growing or decaying, we assume continuous growth or decay, okay? So the only time you're going to use this formula is when you're dealing with something that's compounding non-continuously. I don't know if that's a word, but not continuously, okay? Does that make sense?
Yes.
Now, let's go a little further. And I don't know if you were asking about this, but when do you use this formula versus that formula? Well, here you've got something that's growing or decaying continuously. Here you've got something that involves half-life, because you've got a base of a 2 raised to a negative exponent, which is like having a half to a positive exponent. So if you're dealing with some radioactive substance, something that talks about half-life, that's when you're going to use that formula. Okay. There was another formula that was, let's see, t equals the natural log of 2 over r. That's when you're doubling how long it takes to double a population. If you know the growth rate, you can determine the time just by going straight there. You can also get there using this formula, but you've got a bunch of extra steps. So this is sort of a shortcut to get there. All right, what else?
Yeah, I forgot the shortcut, and then I ended up having to go through all the steps because I barely did the shortcut.
Yeah, but it still works. You're a better man for it, right?
Yeah, it was frustrating.
Yeah, my wife says that that builds character. So what a character you are. So any other questions specifically from the chapter 11 test, Daniela? Anything more you wanted to look at?
No, that was it from that test.
Okay. How about you, Greg? Anything from the test?
Can we go over number 9?
Sure. Do you want to just tell me what it is, or share it, or how do you want to do this?
Yeah, I could share it. Hold on, let me check
Okay, give me a second here to click on the security. Okay, so you should be able to share it now, hopefully. Is it not working?
Okay. No, I've never done that before, so.
Oh, okay.
Never,
so down at the bottom of your screen, there should be a green arrow that says share screen.
Okay.
Click on that and then click on the upper left box that shows up. And that should be sharing what's on your screen. Here we go.
Okay.
There we go. Excellent. Okay, so number 9.
Yeah.
All right. An account now contains $3,610 and has been accumulating interest, 9% compounded continuously. Okay, so the key word to this whole thing is continuously. See where it says continuously?
Yeah.
So we're going to use A equals P e to the RT power. P, the starting amount is, aha. The starting amount we don't have. They give us the ending amount because it says it now contains $3,610. Okay.
Okay.
The interest rate is 9% or 0.09. And time is 5 years. And they want to know the beginning amount. Okay, so now I'm going to go back to my screen. Let's see. Yes. And so can you see my screen now?
Yeah.
We know the ending amount, so we know A. We don't know the beginning amount, which is P. We know that R is 0.09 and T is 5. We can simplify further. If we take 0.09 times 5, we get 0.45. We're trying to solve for P. So we're going to divide both sides by e to the 0.45 power. So P equals $3,610 divided by e to the 0.45 power. And on our calculator, 3610 divided by e to the 0.45 power, I get 2301.837. So that's going to round up to $2,301.84. So again, you've got to be careful and read this problem. It gives you the ending amount rather than the beginning amount. Does that make sense?
Yes, that's where I messed up on the test.
Greg, how about you? Is that working? You still there?
Yeah, I was talking and I thought I had the mute button on.
Okay, yeah, I've done that too. Anyway, does that make sense?
Yeah, it makes sense. I knew it wasn't what it seemed or what you had to kind of go at it like.
Yeah. Okay, something else.
So on the test and some recent homework assignments, there's been problems where it like mentions the population growth, like say like 6.8 billion. But how would I write that? Like, because I know you're supposed to write it as a decimal.
Okay, now wait a minute. The population growth is 6 billion or the population is 6 million?
This population is 6 million, but it gives you like a percent rate that it's growing at.
So the percent rate, that's going to be the R.
Right.
The population is going to be the P, the starting population.
Yeah. So how would you, I know you wouldn't write 6.8 in the P. So what would you write there?
Okay. So, all right.
I don't know if that makes sense.
Let's just make one up. So you're saying that the population was 6.8, let's go million. Okay. Something like that.
Yeah.
And the growth rate we'll say is 3.2%. And time we'll say 10 years. Okay. So we've got a population of 6.8 million growing at a rate of 3.2% annually for 10 years. What's the new population? All right. Now, if they give you the answer, or excuse me, if they give you the information written that way, we're going to put 6.8 in for P, but keep in mind it's in millions. So the way I would write this would look like this. Just to remind me, I would say in millions, okay? When I get my answer, let's just say that it's 9.2. We come up with that for A. Okay, I have no idea what it would be without doing it, but it would be 9.2 million. Now, you could write it like this, but typically, if they give you it with a word, drag the word through the problem and give the answer using the word. If they wrote 6,800,000, put that in the place of P and give your answer written out. Does that make sense? So be consistent with the way they give you the initial information.
Oh, okay. So that was one of the problems on the test. It said 6.8 billion.
Okay.
But sure on if I were to write just 6.8 or how you said, like, write it out.
If it was written in words, if a billion was written in words, I would put 6.8 in for P, but then your answer in the answer box next to it, did it have the word billions still?
That I don't remember.
Okay,
but
it should have been that would be my guess, that if it said the population was 6.8 billion, then your answer should be something like A equals how many billion, and then you'd put whatever number in there, but make sure it has that word after it. Okay.
Okay.
Does that make sense?
Yes, it does. Thank
Okay.
you.
What else? Anything else from the chapter 11 test?
That was all I.
Okay. So what do you want to look at? Or let's just do this. Let's go to chapter 6. Chapter 6 was factoring. Is there anything that you want me to go over in the way of review for factoring?
No, I'm all good with factoring. Thank you.
Okay, Greg, how about you?
No, I think I'm all good with it. There's nothing off the top of my head I can remember from 6, really.
Okay.
It all kind of blends
Chapter
together.
7. Oh, sorry, I didn't mean to cut you off there. Chapter 7, simplifying radical expressions. That's where we added, subtracted, multiplied, and divided polynomials. That involved doing some factoring and reducing out common factors, getting least common denominators. Do you need anything to do with that?
No.
Simplifying complex fractions.
That's when it would give you two binomials, right?
Well, let me just give you an example. So here's a complex fraction. I know my writing is I should have been a doctor. 8x minus 64 over y, and then we've got x squared minus 64 all over y squared. And so you multiply it by the LCD over the LCD, and you distribute and reduce it and all that stuff. Do you want?
Oh, yeah, I remember that.
Okay, how about you want an example or not?
Yeah, let's get an example of it.
Okay, let me rewrite that a little nicer, and we'll take a serious look at it. So 8x minus 64 over y, all divided by x squared minus 64 all over y squared. So what I'm going to do, I'm going to find the least common denominator of all of those denominators, which would be y squared, and I'm going to multiply by y squared over y squared. And the reason I put those little ones in there is just kind of remind you that that y squared on top is on the top of the top, and the y squared on the bottom is on the top of the bottom. In other words, this lines up with that. Does that make sense?
Yeah.
Yes.
Okay, so now we're going to distribute this times that, and we're going to get a y and a 1. So we're going to have 8x minus 64 times y. Okay. And on the bottom, the y squareds will cancel or reduce out, and we'll have x squared minus 64. So far, so good?
Yes.
Now, I can factor an 8 out of that binomial. So I'm going to get 8 times x minus 8 times y. And on the bottom, that's the difference of two squares, x plus 8, x minus 8. So now those common factors reduce out, and I'm left with 8y over x plus 8. You all right with that?
Yeah.
Yes,
Do you want another example, or shall we go on?
I'm fine.
Yeah, I'm good.
Okay. The next section was solving rational equations, where you had an equation containing fractions and you multiplied both sides by the least common denominator to clear out the denominators, et cetera, et cetera. Do you want to look at something to do with that?
Yeah, can you do one of those examples, please?
Sure. Okay, let's see. Let's say we've got 3 over x minus 2 plus 1 over x equals 6x plus 4 over x squared minus 2x. Okay, now we need to find the least common denominator, and to do that we need to factor each denominator. So we're going to have 3 over x minus 2 plus 1 over x equals 6x plus 4 over x times x minus 2. So basically that denominator, I factored it further. Now, considering the three denominators, my least common denominator, I would need an x and I would need an x minus 2. This contains x minus 2, this contains x, and this contains both of them. So there's my least common denominator. Are we okay with that?
Yes.
So now I'm going to multiply both sides of the equation by x times x minus 2. X times x minus 2. Can you see this over here that's off in the gray? Does that show up?
Yes, it does.
Yeah, it's weird that I can write over there, but whatever. Okay. So now distributing here and here and here, I've got x times x minus 2 times 3 over x minus 2 plus x times x minus 2 times 1 over x equals 6x plus 4 over x times x minus 2 times x minus 2. So I'm just distributing. Going across and reducing, I get 3x plus x minus 2 equals 6x plus 4. You see how everything reduced out there?
Yes.
So now I have an equation with no fractions. On the left side, I can combine like terms. 4x minus 2 equals 6x plus 4. I'm going to solve for x on the right side. So I'm going to subtract 4x from both sides. Negative 2 equals 2x plus 4. Subtract 4 from both sides. Negative 6 equals 2x. Divide by 2, x equals negative 3. Now, when I get to this point, I need to be careful, and I need to take this solution and plug it in to all the denominators to make sure it doesn't make something undefined. Here, if x was 2, we'd be in trouble, but negative 3 is fine. Here, if x was 0, we'd be in trouble, but negative 3 is fine. And here, either 0 or 2 would cause trouble. So we don't have any trouble there. So x equals 3, or negative 3, excuse me, would be the correct solution. But you want to make sure, because sometimes you get an answer that doesn't work. Those are these extraneous solutions kind of thing.
Right.
All right. Are you okay with this? Do you want another example of it, or shall we move on?
No, I'm okay with it.
Greg, how about you?
Yeah, I'm okay.
All right. Do you want me to do one where you're solving formulas?
Yeah, please.
Okay, how about this? 2 divided by C plus 2 divided by D equals 1 divided by H. And we are to solve for C. C is in the denominator. We need it in the numerator. So what we're going to do, we're going to multiply both sides by the LCD, which is CDH. All right. So I'm going to take CDH times 2 over C plus CDH times 2 over D equals 1 over H times CDH. On the left side, the C's reduce and I have 2DH. The D reduces and I have 2CH. The H reduces and I have CD. I'm trying to solve for C. There are 3 terms in this equation. 2 of them contain C. So let's put all the terms with C on the same side of the equation. So I'm going to subtract 2CH from both sides. So I get 2DH equals CD minus 2CH. Okay. Now, here's the tricky part. We need to get C by itself. How we're going to do that is we are going to factor the C out of both terms on the right side, leaving behind D minus 2H. Okay, see what I did there?
Yes.
Now we're going to divide both sides by D minus 2H, and C equals 2DH over D minus 2H. Okay. Let's see. Do you want to look at some a story problem from this section?
Sure.
Yeah.
Okay. Let's see. We had number problems. Let's see. How about this one? If a number is added to the numerator of 3/4, we'll call the number x. So if a number is added to the numerator of 3/4 and twice as much is added to the denominator, the result is 4/7. So I'm calling the number x. I added x to the numerator, twice x to the denominator. All right. So call it x. Now, I need to solve for x. I have an equation containing fractions. The least common denominator is going to be what? 4 plus 2x times 7? Because this, yeah, okay, so I'll go 7 times 4 plus 2x and 7 times 4 plus 2x. So on the left side, I get 7 times the quantity 3 plus x. On the right side, I get 4 times the quantity 4 plus 2x. Okay. So now I've got 21 plus 7x equals 16. That's supposed to be equals plus 8x. I'm going to solve for x on the right. 21 equals 16 plus x. Subtract 16, 5 equals x. Well, let's see if that's true. If x is 5, 3 plus 5 over 4 plus 2 times 5 would be 8 over 14, which can be reduced down to 4/7. So the number is 5. All righty. Let's do a problem involving, how about comparing interest rates? Or we good to go?
Yeah, we're good.
Okay.
Yeah.
Comparing investments, it says, an amount of money invested for 1 year in a savings account will earn $1,500. That same amount of money invested in a mini mall development will earn $6,500 interest in a year. Because the interest is paid is 10% more than that paid by the savings account. So you make more off the mini mall development. but it's also a higher risk. Find the rate of interest paid by each investment. Okay, so we're going to make a table. And let's see here. I equals P R T. And we've got the savings account and the mini mall. Okay. An amount of money invested for 1 year in a savings account, so the time is 1 year, will earn $1,500 interest. That same amount of money invested in a mini mall development will earn $6,500 in 1 year. Because the interest paid is 10% more than that paid by the savings account. So if the savings account interest is R, the mini mall would be R plus 10%. Okay. Now,
Right.
the other thing we know, it says that same amount of money invested, blah, blah, blah. So the principal on both is equal. Okay. Now, next thing I'm going to do is I'm going to go back here and I'm going to change this to decimal form. So it's going to be 0.10. Okay. Now, if I equals PRT, then P equals I divided by RT. You following?
Yes. Yes.
So this principal would be 1,500 divided by R times 1, which is still R. This would be 6,500 divided by R plus 0.10, all times 1, which is still the same thing. So what we get is this equation. 1,500 divided by R equals 6,500 divided by R plus 0.10. So basically we set everything equal to the principals because the principals were equal. So now it's just like the last problem. I'll multiply both sides times R, R times R plus 0.10, R times R plus 0.10. On the left, the R's go and we have R plus 0.10 times 1,500. On the right, the R plus 10s go and we have 6,500 R. On the left, distributing the 1,500, we get 1,500 R plus 0.10 times 1,500 would be 150. I'm going to subtract 1,500 R from both sides. 150 equals 5,000. Oops, 5,000 R. Divide both sides. Hang on here. Come on, eraser. Don't fail me now. Okay, so we've got 150 equals 5,000 R. We're going to divide both sides by 5,000. So R equals, let's see, calculator time, 150 divided by 5,000. And I get that. So R would be 3% and R plus 10% would be 13%, converting them back into percents. So the question, it said, find the rate of interest paid in each investment. The savings account, 3%, the mini mall, 13%. All right with that?
Yes.
Okay, let's do a rate, distance, time problem. Are we good to go on?
Yes.
Yeah.
Okay. This says boating. A boat that travels 18 miles an hour in still water can travel 22 miles downstream in the same time as it takes to travel 14 miles upstream. Find the speed of the current in the river. So this problem has to do with distance equals rate times time. And we've got upstream and downstream. Okay. Now, it says the boat can travel 18 miles an hour in still water. So that's without the current pushing it or pushing against it. The boat can travel 18 miles an hour in still water, can travel 22 miles downstream in the same time it takes to travel 14 miles upstream. Now, in the same time, so the times are the same. Okay. Now, let's let x equal speed of current. Okay. So going upstream, it said the boat could travel 18 miles an hour on its own, but it's minus the current because the current is working against it. Going downstream, it's got 18 miles an hour plus the current is helping it. Okay. Now, D equals RT, so T equals D divided by R. So this is going to be 14 divided by the quantity 18 minus X. And this is going to be 22 divided by the quantity 18 plus X. Since the times are equal, we get this equation. 14 over 18 minus X equals 22 over 18 plus X. All right. So my LCD is going to be what? 18 plus X times 18 minus X. So here I'm going to have 18 plus X, 18 minus X, 18 plus X, 18 minus X. On the left side, the 18 minus X's are going to cross out. I'm going to have 14 times 18 plus X. On the right side, the 18 plus X's are going to cross out. And I'm going to have 22 times 18 minus X. I feel like I'm traveling at the speed of light. You feel like I'm traveling at the... We'll get through this problem though. Let's see. 14 times 8, oops. 14 times 18 is 252 plus 14x equals 22 times 18, 396 minus 22x. Add 22x to both sides. We get 36x plus 252 equals 396 minus 252. 36x equals what? 144. Divide both sides by 36x equals 4. Now, the question said, find the speed of the current. Oh, there it is. 4 miles per hour. Okay. Let's see. And that kind of got us through chapter 7. So basically tomorrow we'll just pick up from here. And we can even go back if you decide, oh, I want to look at some factoring or whatever, but we'll just spend the hour that we have looking at anything you want in terms of reviewing for the final. I'll be back at 1:15 today as well as tomorrow for an office hour if you have questions and want to come there. Otherwise, I will see you tomorrow.
Alrighty, have a great day, Mr. Mayo.
You too.
Thank you. Have a good day.
Bye-bye.
You too. All right. We'll